I don't say those words. Okay. So welcome to part 25 of today's lecture. Okay. Sponsored by just about every commercial there could be, because it keeps going on. Okay, sponsored by whoever just scam called me. All right. So Bohr was able to, he observed this. So when we look at this hydrogen light, all 21 of these are being given off at the same time. We can only see these few that are only ones that our eyes are sensitive to. These are all in the ultraviolet region, okay? And it's called the Lyman series, okay? This is the visible light, which we call the Bohr series. Did it backwards. Got to be consistent. Bohr. These are in the infrared, and that one's easy to remember because it's called the Passion series. Okay, because passion and red go together. Okay? And then over here, these last ones, one of them's called the I don't know which one's which. One of them's called bracket, and the other one's called, I don't know what language that puts the P in front. That you don't pronounce it, but the fund. Okay? Okay, somebody's last name, I'm guaranteed. So all of these are being given off. The only ones we see are these, so when you mix these colors all together, we get magenta, we get the color that we're seeing. But it's not a continuous spectrum. It's what we call a bright line spectrum.
Isn't there one more? Like you have one for, like you have the big one UV, and you have visible, and are the next two infrared?
They're all the rest of them are infrared. Okay. Because notice the energy levels are getting closer and closer, so the energy changes are very, very similar. And the infrared range is pretty long, pretty big range too. But there are a lot more parts of the electromagnetic spectrum. Okay, up here above UV, you can go to X-rays, and then cosmic radiation even above that. Down below infrared or radio waves, TV waves, power line, electrical waves. Okay, so there's a whole bunch. Okay. So, Bohr observed all this, and he said, well, how can that be? How can it just give off these individual colors like this, these individual lines? What's going on? And he said, well, the electron must be, and this is where, he talked about his hotel, the electron's making these quantum jumps. That you put electricity in, and then they make the jump back down, but just like he said on the video, in the hotel, you can only go from one floor to the next. You can't stop anywhere in between. Okay? So he's saying that we have fixed energies. And that the genius is that he was able to calculate the fixed energy and say that the energy on any energy level n is going to equal negative 2.18 times 10 to the minus 18th joules divided by n squared. Okay? So if you plug in 1 here, well, the electron's obviously going to have negative 2.18 times 10 to the minus 18 joules. You divide it by 2 squared, 4, then you're going to have how much energy it has on the second. 3, 4, 5, you can calculate how much energy it has there. So if we're looking then at the transition between 3, say, to 2, well, it's going to be the energy of 2 minus the energy of 1. Pardon me, it's opposite. It's final minus initial. And I did 3 to 2, so I didn't even use the same numbers. Okay? Try again there. Okay? So, it's how much energy it has on 3 and 2. And they switch it around for sign purposes. But 3 to 2, it's always final minus initial. That's how much energy is released in the photon when the electron makes that transition. Now, he didn't know, well, by the time he did this, Einstein had already written his paper on the photoelectric effect and identified light being given off in photons. And so he was able to then realize that that was the energy of the photon.
Isn't it kind of stupid though? Einstein hated Bohr's quantum theory, but he proved that there were photons.
He proved they're photons. He proved light had a dual nature, okay, and that the light is a wave, but it has the photons, the particle nature to it, which then we're going to find leads to the discussion of the electron having a dual nature as well. Okay, that's yet to come.
So the maximum energy an electron can have is 2.18 joules, or times 10 to the negative 18.
Yeah, actually, it becomes less negative, which eventually it goes to 0, which means that's the escape. So this is the energy, so you take the positive of that, that's how much energy you have to put in to ionize it, to knock it off.
Is
Okay?
that the conduction then? Or like, breaks free?
It just breaks free, it just goes off and you make an ion. Okay, so once you get above 7 and you get to 8, 9, 10, mathematically they're all possible, but the electron is so far from the nucleus that the attraction is very weak. So we generally just talk about 7 energy levels. Okay, 7 rows on the periodic table. That's kind of where we are. Okay, so this was huge. Took him years, took him a long time to figure this stuff out, but when he did, he was just saying, in order for us to be able to explain the observation of how we see these individual lines, the electron has to be jumping from one fixed energy level to another. And then because you're dividing by n squared, the levels tend to not be evenly spaced because you're not going to be dividing by the same number. It's not a linear function, it's a squared function, you know, a quadratic function. Okay? So, that's where Bohr, now the argument starts, okay, well, how can it make these quantum jumps? How can it just do something that, you know, we don't understand from physics point of view? And what we're going to learn is that quantum mechanics is a whole new set of rules. Now, the word quanta itself, does anybody remember what it means? No, you guys can't answer.
Like a small packet.
Yes, a quanta of energy is a small packet of energy. But the word quanta or quantum is actually a Latin word. Most of the time I make up the Latin words, but this one is real. Okay?
Like the Hobbs constant.
Yeah. So a quantum means a specific amount. So if you get a quantity of apples, you're getting a specific amount of apples. A certain quantity of something is a specific amount. It comes from the same Latin root word. Okay, so we're talking about the quantum theory is that the electron can only have specific fixed energy levels. It can only gain and lose energy in very specific amounts. It can't randomly gain and lose energy. There's these certain floors of our hotel orbital that the electron can only be on. Okay? All right. That sets the stage now for the battle royale.
Oh.
And you can stop it.